Hey there, Alexa. I was really hoping to avoid using my gamer headphones in order to make this video for you, but this is my fourth attempt, and I have yet to find a way to get this to work where you get to see the desk as well as see, me at the same time. So, I don't know how much that matters to you, but to me, I think it's a big deal that you get to see both. Let me see if I can make this any bigger at all. Slightly. Okay. So I'll try to keep everything in the camera view. That way we can see what we are doing. All right, there we go. All right, so what I want to do is give you a quick overview of how to use the equipment that we're going to use in this lab. That's the game plan. Okay, so as you can see down here, I've got a multimeter and a whole bunch of wires and a little resistor. Bink, this little guy. All right, we're going to look at all of these together. And yeah, first I'm going to show you some different things that we've got here. And actually, maybe I should go back a little bit. All right, so notoriously difficult to get on and off, but very handy little things here. All right, so we've got some wires. I'm going to move them out of the way. We're going to begin with your battery and your multimeter in general, and then I'm going to switch over to how to read a resistor, and then I'll go back to how to find the current that's going through your circuit. Okay, so digital multimeters. Here's the multimeter that you're working with. Let me make sure I can get this all in the right view. There we go. We'll do the best we can. There. It's not perfect, but it's pretty good. So hopefully you've got your multimeter out and you're looking at it. All right, so over here on this side, it says DCV. That stands for direct current voltage. That's going to be the reading set where we figure out what's going on with your battery. AC means alternating current. We are not studying alternating current, so that is not something to worry about. And then this little guy over here, honestly, I can barely read that, but we're not using that either. All right, DCA. This is for the current. This is direct current being read in amperes or some form of ampere, maybe a microampere or a milliampere. In any case, this is where we're going to read the current. All right, now the main rule in my book is that you keep this off when you actually turn the dial from one section to the next section. I mean, if you're going through the readings on this side and they're all part of the amperage stuff, you don't have to turn it off. But if you're going from amperage to current, which I'm about to do, I ask that you do that with the power off because there are fuses inside the multimeters that I do not have replacements for. If they blow, I have to hotwire the thing in order to have enough for everybody. So I just ask that you don't do that. All right, so just turn it off. That way we don't get a power surge. We don't bust the fuse. Ask me how I know this happens, right? Learn the hard way always. All right, so I don't know how easily you can see that, but I have it set on the 20. All right, this is a 9-volt battery, so 20 is the maximum reading that I would get, and obviously 9 is less than 20, so this will work out just fine. You can turn it on at that point. Now, when you're going to measure your battery, all you really need to do is touch the leads to the battery itself. Let's see if I can get that in the video. There we go. All right. Now, if you get a negative number for this, I'm tangled up. All right, let's try this. If you get a negative number for this, it's not a big deal. It just means that you flipped things around the wrong way, right? So, if I flip them, you notice my number's negative, but it's the same dang number. So I don't care about positive or negative. I just want it to read properly. All right, so take a reading for your battery. That will be the reading for the entire battery for every possible combination that we do. All right, you've got the voltage good to go. All right, so then we can turn it off and get ready. I'm going to flip it over here to the top reading in DCA. All right, just so that you know. All right, so I'm going to put this aside for a minute. We are looking at relationships between voltage, current, and resistance. Now, current we're going to measure in just a moment. But what about resistance? How do we figure that out? Well, we have these little ceramic guys, these little ceramic resistors, and you can see they've got colors on them. There's 4 bands. The 4th band is the tolerance band, the gold band. Okay, so that, first of all, it tells me like where the, like that this side right here, that is the end. All right, the colors actually stand for numbers. And when I figure out the resistance, this is going to be the end, the gold. All right, so let me show you how this is. Let me show you how this is going to work. You notice you've got a little chart right here with what each color stands for. So I'm going to be referring back to that, but actually, I'm going to grab a blank notepad because it'll just be nicer if I can find a blank sheet. Right? We'll try it like this. Okay, so when I look at this, and my eyeballs, they're not so great, but I have looked at this one several times today. The colors that I have are gray, and then red and red. Or did I have red and orange? I had red and orange. Yeah, red and orange. And then gold. These are the colors that I have. So looking at your chart, looking at this right here, follow along with me as we go, all right, so that you can see what I'm doing. All right, so the gray, that is the number 8. So that means I'm going to start here with an 8. The second digit is my red, and that is, of course, a 2. Now, this one is the one that usually tricks people out a little bit. The third color band tells you how many zeros to add. So I have an orange band that is 3 zeros. So 1, 2, 3. All right. The gold tells me that I have a plus or minus 5% tolerance. That doesn't mean that I have to do any math, but realize that if there's going to be any difference in what you're doing, like the numbers that you predict versus the numbers you actually measure, they should hopefully fall within that 5% higher or lower range. Okay, so this resistor would be 82,000 ohms. That's how we do it. So you're going to do that for 5 different resistors. If you have a resistor, I'm going to send a handful of resistors home, but if you have a resistor that's under 100 ohms, I want you to put that one aside because you'll have so much current that you'll probably smoke the resistor and it's going to smell terrible and it's going to get really hot. So I don't want that to happen. Anything over 100 up to like 10 million, you're good. You'll be able to take readings with no trouble. Okay? All right, so now go through. Keep them organized so you know which one is where. That's kind of critical to do in this lab. All right, so once you've got everything all figured out, I'll come back to that in a minute. Next, we're going to hook up our circuit. I want to point out to you that you've got a picture of the schematic right here. I want you to set it up exactly like that. And the wires and the alligator clips, they just help connect everything, right? So what this is telling me is that the battery should have 2 wires. One of those wires should go to the multimeter. The other one should go to the resistor. The resistor should have 2 wires. One should go to the battery. One should go to the multimeter. You get the idea. Follow it like a recipe. It tells you exactly what to connect to. All right, so once you've got everything ready to go, give me 1 minute here. I'm going to put all my things together. It is totally up to you if you want to use this little guy or not. They're hard to get off, but they are kind of helpful when you want to connect things to them. See? I mean, like they hook up really nice to the alligator clips. All right, so let's unwind this again. Alrighty. Put my little wire there and put one there and what am I missing? What am I missing? Oh, I'm missing something back to the battery. That is what I'm missing, my friends. Let's see. All right, hang on 1 second. I've made a spaghetti mess. I'll be right back. Let me fix it. Okay, there we go. I'm back. I'm uncluttered now. Alrighty, so we should be good to go. Now, assuming that you've got everything all hooked up, I know I didn't really show you, but that's okay. You got to figure some stuff out. All right, so now here's what I want you to do. I want you to make sure that you're over in the DC amps. You're going to start on the 2000 or the 200 microamps. That is your most sensitive current reading. All right, when you turn this on, we hope, there we go. All right, now what I'm going to do is I'm going to complete the circuit. You notice how it went straight to number 1. That tells you have too much current for that setting. So you can just leave it there if you want, and I'm going to flip it 1 down. So now I have a maximum of 2,000 microamps for this. And as you can see, I got something on there that's not a 1. It looks like a huge number. All right, let's remember what that is. So let's grab this back again. What did we say we had? 1021 microamps. Knowing exactly what the unit is, the first 2 are micro and then the bottom 2 are milli. All right, that's really important. So let's move this out of the way now and I'll bring back my paper. There we go. So when I read it, it's 1021 microamps. I need to know how many amps that is. So the key thing to remember is that if I remember back to the way you used to solve things in chemistry with dimensional analysis, right? 1 amp is my bigger unit, or the amp is my bigger unit, so it gets the 1. There are 1,000,000 microamps in an amp. So I'm going to take this 1021 and I'm going to divide it by 1,000,000. And then I will know how many actual amps I have. It's going to be a small number. That's not surprising, right? But okay, so I'm going to divide this by 1,000,000, and can we see it? I think we can. 0.001021 amps. That is the 1021 divided by 1,000,000. You can leave it like this, or you could write it in scientific notation. That does not matter to me. It's the same value. All right, so you can either write it full out or as scientific notation. All right, so you get the first one done. You're like, wow, this is great. I love electricity, Mrs. Grady. Thank you so much. That's fabulous. Do all 5. Then what I'm going to ask you to do is to fill out this chart. All right, this number is going to be constant because the battery is the same battery for everything you've done. This is where your measurements are going to be. Notice it's in amps. You have to do all your converting. Okay. Resistance, that's from reading the color bands. This is actually taking your voltage divided by your resistance, and you should get a value here. And then as you notice on question number 1, the discussion questions toward the bottom, they want you to compare this final column here to this column and explain why those numbers should be similar using Ohm's law. Okay? And then possible source of error. Those are the main things I want you to complete. Now, what do I want you to turn in? Well, I definitely want a picture of your chart and I want a picture of the answer to your questions. But what I would also like to see is I would like a short Flipgrid video that shows the circuit being put together. And I mean, if you've put it together and you want to start there, that's fine. But then showing you taking one of the readings and doing the math to figure out the current for me. So I know you know how to hook it together and actually take a current reading from it. That's what I would like on the Flipgrid video. And I will send you a link to that particular activity. I just haven't put it together yet. All right. So hopefully this 4th iteration of showing you how to do this lab is going to stick. And I'm going to actually have usable video to send to you. All right, kiddo, keep in touch. Let me know how you do. Good luck.